Hey there, space explorers. Get ready to have your minds blown because today we're diving into the mysterious world of black holes. These are some of the most powerful and strangest objects in the entire universe. You might have heard about them swallowing up anything that gets too close, even light. What exactly is the edge of a black hole? That's called the event horizon. It's like a one-way door. Anything that crosses it can never come back out. Imagine it like a waterfall. If you get too close to the edge, the water's flow will pull you over and you won't be able to swim back up. Similarly, anything that gets too close to a black hole's event horizon will be pulled in by its immense gravity. The event horizon is also where strange things happen to time. If you were watching someone fall into a black hole, it would look like they were moving slower and slower as they approached the event horizon, and eventually they would appear to freeze. But to the person falling in, time would feel normal. The event horizon is a fascinating and mysterious boundary that marks the edge of the unknown. It's a place where the laws of physics as we know them start to break down, and scientists are still trying to understand all of its secrets. Ever wondered what's at the very center of a black hole? It's a place called the singularity, a mind-boggling point where gravity becomes so intense that the laws of physics as we know them break down. Imagine taking all the stuff in the universe and squishing it into a single tiny dot. That's kind of what a singularity is like, but even more extreme. It's a place of infinite density where space and time get twisted and warped beyond recognition. We can't see singularities directly because they're hidden inside the event horizon, the black hole's point of no return. But scientists believe they are there based on our best understanding of gravity. The singularity is one of the biggest mysteries of the universe, a place where the very fabric of reality seems to unravel. Black holes come in different sizes, just like stars. We will discuss most common types. Did you know that not all stars are destined to shine forever? Some of the biggest and brightest stars in the universe have a dramatic ending in store. They become stellar mass black holes. When these enormous stars run out of fuel, they can no longer fight against their own crushing gravity. The star's core collapses inward, squeezing tighter and tighter until it becomes an incredibly dense point called a singularity. Surrounding this singularity is an invisible boundary called the event horizon. Once anything, even light, crosses this boundary, it cannot escape the black hole's intense gravitational pull. Stellar mass black holes are typically a few times to several tens of times the mass of our sun. Imagine squeezing all that matter into a space smaller than a city. Despite their relatively small size, they pack a powerful punch, influencing the space and matter around them. Although we can't see black holes directly because no light can escape them, we can detect their presence in a few ways. They can create swirling disks of hot gas that emit X-rays, which astronomers can detect with telescopes. Black holes can also be found by observing the way they tug on nearby stars, causing them to wobble in their orbits. Studying stellar mass black holes helps us understand the life cycle of stars and the extreme forces at play in the universe. It's like peeking behind the curtain of the cosmos and witnessing the incredible power of gravity in action. Supermassive black holes are millions or even billions of times heavier than our sun. They live in the centers of most galaxies, like our own Milky Way. Imagine a black hole so big that our entire solar system could fit inside it. That's how massive these things are. But how did they get so big? Well, scientists aren't exactly sure, but they have some cool ideas. One theory is that they formed early in the universe from giant clouds of gas. Another is that they grew over time by gobbling up stars and gas, like a giant cosmic feast. Supermassive black holes are pretty amazing. As gas and dust spiral into them, it gets superheated and forms a bright swirling disk called an accretion disk. This disk can outshine all the stars in a galaxy. They can also shoot out powerful jets of particles from their top and bottom, stretching millions of light years across space. Even though we can't see them directly, scientists have found ways to detect supermassive black holes by looking at how they affect the stars and gas around them. They've even managed to take a picture of the shadow of one, which is a pretty big deal. Supermassive black holes are still full of mysteries. Scientists are trying to figure out how they formed, how they grow, and how they impact the galaxies they live in. But one thing is for sure, these cosmic giants are some of the most fascinating and powerful objects in the universe. The intermediate mass black holes, often called the missing link in the black hole family, they're not as small as stellar mass black holes, but not as gargantuan as supermassive ones. We think they could weigh anywhere from 100 to a few 100,000 times the mass of our sun. Finding these middleweights is a real challenge, though. They don't give off as many flashy signs as their bigger cousins. They don't gobble up stars as dramatically, so they're not as easy to spot with telescopes. So how do they form? Scientists have a few ideas. Maybe they're made when smaller black holes collide and merge together. Or perhaps some giant stars collapse directly into these mid-sized black holes. We even think some might have formed way back at the beginning of the universe. Scientists are searching hard for these missing links. They're looking at weird, bright objects in other galaxies and even in the centers of smaller groups of stars. Each new discovery brings us closer to understanding how black holes grow and evolve and how they shape the universe around them. The hunt for intermediate mass black holes is an exciting adventure, and we're just starting to uncover their secrets. Since black holes don't emit light, we can't see them directly, but we can detect them through their effects on nearby objects. Let's explore some ways scientists find black holes. Einstein, the famous scientist, predicted gravitational waves over 100 years ago. He said that when black holes move around, they create gravitational ripples in space, kind of like a giant trampoline bending when someone jumps on it. These ripples are actually stretching and squeezing space as they travel at the speed of light. These waves are super tiny, though, so tiny that we need incredibly sensitive detectors to find them. Think of them like tiny whispers from the universe telling us stories about events that happened millions or even billions of years ago. So what do these whispers tell us? They tell us about some of the most extreme events in the universe, like two black holes colliding. These events are so powerful they send out these ripples which travel across the universe until they reach us. By studying these waves, scientists can learn more about how gravity works, what black holes are really like, and even how the universe began. It's like opening a window into the past and seeing events that no one has ever seen before. So the next time you see ripples in a pond, remember that there are similar but invisible ripples traveling through space, carrying with them secrets about the universe's most amazing events. Just like visible light, X-rays are a type of electromagnetic radiation. The difference is that X-rays have much more energy and shorter wavelengths, which makes them invisible to us but able to penetrate through objects that visible light can't. In space, black holes produce X-rays. These X-ray emissions act like cosmic fingerprints, telling us what's happening in these far-off places. To detect these X-rays, scientists use special telescopes in space. These telescopes are equipped with instruments that can see X-rays just like our eyes see visible light. By studying the X-rays coming from black holes in the universe, astronomers can learn a lot about them. They can determine their temperature, composition, and even how they're moving. For example, the X-rays emitted by the hot gas swirling around a black hole can help scientists measure the black hole's mass and spin. So while X-rays might be invisible to our eyes, they are a powerful tool for unlocking the secrets of the black holes. By studying these high-energy emissions, scientists can learn about some of the most extreme and fascinating phenomena of the black holes. Another way to detect black holes is the motion of stars. Imagine a black hole as a cosmic bowling ball sitting on a giant trampoline, spacetime. Just like a bowling ball would warp the trampoline, a black hole warps the space around it. Now imagine rolling a marble, a star, on that trampoline. It won't go in a straight line. It will curve around the bowling ball due to the warped surface. This is what happens to stars near black holes. They don't just move in straight lines, but follow curved paths. Due to the black hole's gravitational influence, sometimes a star might get too close to the black hole and get trapped in its orbit, like a planet orbiting the sun. But there's more. The black hole's gravity can also cause the star to wobble. This is because the black hole pulls harder on the side of the star facing it, compared to the side facing away. This uneven pull causes the star to rock back and forth as it orbits. Astronomers can detect this wobble through careful observations, and it's one way they can find black holes that are otherwise invisible. The dance between stars and black holes is a complex and fascinating one. By studying the motion of stars near black holes, scientists can learn a lot about these mysterious objects, like their mass, and how they interact with their surroundings. It's like watching a cosmic ballet, where each star's movement tells a story about the hidden forces at play. Black holes are more than just scary monsters in space. They're also powerful tools that help us understand the universe. By studying them, we can learn about the nature of gravity, the structure of space-time, and the evolution of galaxies. Who knows what other secrets they might reveal in the future? Black holes are a fascinating and complex topic, and we've only just scratched the surface here. But we hope this video has given you a better understanding of these amazing objects and sparked your curiosity about the mysteries of the universe. Keep exploring, and who knows what you might discover. Please like, comment, and share the video, and please do not forget to subscribe for more videos.